Hey everybody, and welcome to a video on solving absolute value equations. So, let's make it happen. Suppose that we were given the following equation. The absolute value of A equals 5. Well, that means we need to find a number whose absolute value is 5, or any number whose distance from 0 on the real number line is 5. Well, it's clear that 5 is the solution, because of course, 5 is exactly 5 units away from 0 on the number line. But negative 5 is 5 away from 0 as well, so negative 5 is a solution to this equation as well. So how do we write that? In this case, I would split up this original equation, and I'd say A could be 5, or A could be negative 5. This equation has two solutions. There are two numbers whose absolute value are 5. What about this next equation? The absolute value of W equals 8. So we're just looking for any number that's 8 away from 0 on the number line. Well, both 8 and negative 8 are 8 away from 0, so those are both going to be solutions to this equation. So we would write W equals 8 or W equals negative 8. One stylistic comment, I like to write my solutions from left to right as they appear from left to right on the number line. So A equals negative 5 or 5 because that corresponds to their position on the number line. Same thing with negative 8 and positive 8. So what about this last equation? Why don't you give this one a try? Not surprisingly, the two solutions to this equation are positive 10 and negative 10. And in general, to solve an equation of the form, the absolute value of some variable equals a number, we're going to split this equation into two separate equations. Either our variable could equal that exact number, or our variable could be equal to the negative of that number. Of course, this original number has to be non-negative because it's impossible to take the absolute value of anything and have it be negative. Alright, with this in mind, why don't you pause the video and try to solve these four absolute value equations in front of you. Alright, I hope the first two weren't too bad for you. Of course, if the absolute value of some number m is 12, m has to be either 12 or negative 12. If the absolute value of some number d is 19, well, then d could be 19 or d could be negative 19. Now, if we ever have an instance in which we have the absolute value of some thing is 0, then that means this thing needs to be 0 units away from 0 on the number line. It itself has to be 0. So this is one of the very few times when we actually don't split our equation up at all. We just get, in this case, w equals 0. In this last example, we had the absolute value of h was negative 6. But we know that you can never, ever, ever take the absolute value of anything and have it be a negative number. So if we ever have an equation in which we take the absolute value of anything and it's negative, boom, right away we know the equation has no solutions. Now, note, right now in this general form, this x represents a variable, which just represents a number. But this is going to be the strategy for any equation of the form the absolute value of thing equals a number, where that thing can be any number, any expression, it can have all sorts of stuff going on. We're going to handle it in the exact same way. Either that thing equals the original number, or that thing will equal the negative of that number. Like the absolute value of b plus 3 equals 5. Well, we're actually going to use the exact same strategy because we have the absolute value of something equals a number. So let's split it up in exactly the same way we did before. And let's talk about this with regard to the number line again. I don't know what b is, but we do know that b plus 3, its distance from 0 is going to have to be exactly 5. So, b plus 3 is going to have to be 5, or b plus 3 is going to have to be negative 5. Now, we've got these two equations, and we know exactly how to solve them, so let's do it. So it appears that the two solutions to this equation are going to be 2 and negative 8. And if we take a look at the number line, we can see exactly how we graph our answers on a number line. Now, in a quiz or homework kind of setting, all I'd actually be looking for is this. This is enough to tell the reader exactly what the solutions are to our equation. But having all this is really nice just to see the steps that we did to come to our solution. All right, let's take a look at this next one. Now this doesn't look like anything we've seen before because it's not just the absolute value of something equals a number. We've got multiple things going on over here. Well, that's no problem at all. In general, we're going to want to isolate that absolute value so that we may split up the equation into two like we did before and proceed. So the first thing I would do here is subtract 5 to isolate this absolute value. So we end up with the absolute value of m minus 6 has to equal 8. So I don't know what m is, but I know that m minus 6, since its absolute value is 8, m minus 6 has to equal 8, or m minus 6 has to equal negative 8. Once again, we're left with two pretty simple equations that I think we know how to solve. I think we've got to add 6 to both sides of both of these equations, and we'll find our two solutions. So, it appears to me that our two solutions are negative 2 and 14. And if you were asked to graph these solutions on a number line, all you'd have to do is draw in a point at negative 2 and a point at 14 on the number line. You don't have to have a 0, doesn't have to be a scale. Does it help sometimes? Absolutely, but no need to do it. You're not required at all. Alright, before we finish up, let's try a few more difficult examples. And you're welcome to try these on your own, in which case you can pause the video now and do them and then play later, or you can just play right through and I'll walk you through them. Okay, so looking at this first equation right here, we need to first, before we do anything, take whatever steps are necessary in order to end up with just the absolute value of x plus 8 equals some number. Doesn't matter what this number is, the first thing we always want to do is isolate our absolute value. So, taking a look at our original equation, I think the first thing we need to do is add 3 to both sides. And that's going to give us the new equation, negative the absolute value of x plus 8 is equal to negative 4. Now we're almost there, but we know we need to just have this absolute value by itself. I don't want to have this negative sign hanging around. So let's multiply both sides of this equation by negative 1. And that should allow us to have just the absolute value all by itself. And we end up with the absolute value of x plus 8 is equal to 4. Now and only now are we in a position to go ahead and split this up. If the absolute value of x plus 8 is 4, well, then there are two possibilities for what x plus 8 could possibly be. X plus 8 could be 4, or x plus 8 could be negative 4. And from here, we're looking good. Just got to subtract 8 from both sides of both equations. We end up with x either equals negative 12 or x equals negative 4. And these two are going to be the two solutions to our original absolute value problem. And I urge you to do a quick mental check. Of course, a good idea to graph these on our number line as well. And this is all it takes. Just a point at negative 4 and a point at negative 12. All right, Looking at our second example, of course, once again, we need to do whatever it is we can in order to end up with just the absolute value of 2m minus 5 equals some number. We got to isolate our absolute value. That is our first goal. All right, let's do it. I think the first thing we're going to need to do is subtract 2 from both sides. This yields us 3 times the absolute value of 2m minus 5 is equal to 15. Now, I think we need to divide both sides by 3. Lucky for us, 3 divided by 3 is 1. So now we have successfully isolated our absolute value. So the absolute value of 2m minus 5 is equal to 5. And now, and only now, are we ready to split this up. If 2m minus 5 has an absolute value of 5, then 2m minus 5 equals 5. Or 2m minus 5 equals negative 5. Those are the two options. And from here, it'll just be 2 steps in order to isolate our variable m. Let's add 5 to both sides. I know I'm a little tight on space, guys, so bear with me. We get 2m equals 0, in which case m equals 0. Or we get 2m equals 10, in which case m equals 5. So the two solutions to our equation are m equals 0 or m equals 5. And of course, to graph those on a number line, not so bad. Just toss a point at 0 and a point at 5. All right, 2 last examples before we finish up. Again, if you want to try these on your own, feel free to pause now and then play when you're done. But if you'd like, I can walk you through them right now and just play right through. Okay, looking at our first example, per usual, the first thing we want to do is isolate our absolute value. And I think that's going to take only one step. Let's just subtract 4 from both sides of this equation. And we get the absolute value of negative 3x minus 8 is equal to 0. So this is one of those interesting cases where, because we have equals 0 here, what this means is whatever number negative 3x minus 8 is, its distance from 0 on the real number line must be 0. So that means that negative 3x minus 8 itself has to equal 0. So there's actually no splitting at all in this case. And so now all we have to do is solve this equation. Let's add 8 to both sides. And then I think we will divide both sides of the equation by negative 3. And we find that this particular equation ends up having only one solution, namely negative 8/3, which we can graph on our number line. Now, if this had been a number like 2 or like 4 or like 6, we would have split this up and it would have been negative 3x minus 8 equals 2 or negative 2, or it equals 4 or negative 4, or it equals 6 or negative 6. All right, now for our second one. Again, first things first, we got to isolate our absolute value. In this case, it's going to take a few more steps. So let's start by subtracting 17 from both sides. I think we end up with 4 times the absolute value of w minus 6 equals negative 12. We'll divide both sides by 4. And we end up with the absolute value of w minus 6 equals negative 3. Now maybe we're thinking it's time to split up. But wait a second. What this says is that whatever number this is, its absolute value is negative 3. Remember, it's impossible to ever take the absolute value of anything and ever get a negative number. So this statement is a nonsensical statement. It's obviously false. It could never ever be true. What does that mean? It means that our original equation has absolutely no solutions. So once you see a statement like this, you can stop right away and just say no solutions. Hey again, guys. That's it for this video. I hope you found it helpful and I hope you enjoyed.